Welcome to EduRev.
Hello everyone, welcome to EduRev. So let me introduce myself first. My name is Khushbu Gupta and I have done my post-graduation in chemistry from IIT Bombay. I am your chemistry educator. So I am continuing with the part 4 of the chapter Some Basic Concepts of Chemistry. Let us take a look over what topics we will cover in this lecture video. We will be talking about laws of chemical combination. So basically it is based on 5 basic laws which we will discuss one by one. And then we will talk about Dalton's atomic theory. And after that we will talk about some key terms like atomic mass, average atomic mass, molecular mass, formula mass. The first topic of this lecture video is laws of chemical combination. So basically during a chemical reaction, let's say this. There are some qualitative as well as quantitative observations. In order to account for these observations, it is summarized by certain statements which are known as laws of chemical combination. So there are basic 5 laws that are studied under this, which are law of conservation of mass, law of definite proportion, law of multiple proportion, Gay-Lussac's law of gaseous volume, and Avogadro law. We will study each of the law one by one. The first law is about law of conservation of mass. So this law was put forth by Antoine Lavoisier in 1789. So what he said that matter can neither be created nor be destroyed. What does this mean? Like in a chemical change, the total mass remains conserved. That is, mass before the reaction is always equal to the mass after the reaction. Let us understand this with an example. This example tells about the formation of water where H2 combines with O2 to give water. So if I look at the mass of H2 will be 2 grams. Similarly, mass of half O2 is going to be half into 32 grams. And the total mass of reactants comes out to be 18 grams, right? So if I look at the mass of product, that is water form, it comes out to be 18 grams. As you can see here that the mass before the reaction, which is the mass of reactants, is equal to the mass after the reaction, which is the mass of product. So this satisfies our law of conservation of mass. Let's try to solve this example. It says a 15.9 gram of sodium carbonate is added to the solution of acetic acid weighing 20 gram. The two substances react and liberate carbon dioxide gas. After the reaction, the contents of vessel weigh 29.3 gram. What is the mass of CO2 given off during the reaction? So, if I have to write this reaction, I can say sodium carbonate plus acetic acid released carbon dioxide, and what other parts are formed is sodium acetate and water, right? So if I see the total mass of reactants given is 15.9 plus 20, which gives me 35.9 gram, right? So as per law of conservation of mass, we know that the mass of contents of vessel, meaning जो हमें reaction करके जो vessel में obtain हुए contents, उनका मास भी 35.9 होना चाहिए था, लेकिन हमें मिला कितना 29.3. दैट मीन्स जो बचा हुआ मास है वो किसका है? कार्बन डाइऑक्साइड जो रिलीज हो गई, राइट? सो मास ऑफ CO2 रिलीज इज 35.9 minus 29.3, which gives me 6.6 gram. So the second law is about law of definite proportions. So this law was put forth by Joseph Proust. He worked with a sample of cupric carbonate, and on the basis of his observations, he stated that a given compound always contains exactly the same proportion of elements by weight. What does it mean? So he analyzed sample of cupric carbonate which was of natural origin as well as of synthetic one. What he found in his results is that the percentage of copper, oxygen and carbon was exactly the same, irrespective of whatever was the source. Okay, so what can we say? That a given compound always contains the same elements in the same proportion, irrespective of the source. It is sometimes also referred as law of definite composition. Let us understand this question. It says 2.8 gram of calcium oxide prepared by heating limestone was found to contain 0.8 gram of oxygen. When 1 gram of oxygen was treated with calcium, 3.5 gram of calcium oxide was obtained. Show that the result illustrates the law of definite proportion. So ऐसे क्वेश्चंस हम कैसे सॉल्व करेंगे, देखो फर्स्ट इंफॉर्मेशन दी है फ्रॉम हीटिंग लाइमस्टोन, ठीक है। जो हमें कैल्शियम ऑक्साइड ऑब्टेन हुआ वो कितना था 2.8 ग्राम, और उस कैल्शियम ऑक्साइड में ऑक्सीजन कितना प्रेजेंट था 0.8 ग्राम। ये हमें फर्स्ट लाइन से इंफॉर्मेशन पता लग रही है। सेकेंड लाइन क्या बता रही है, जब ऑक्सीजन को कैल्शियम के साथ ट्रीट करा, दैट इज रिएक्शन ऑफ ऑक्सीजन विद कैल्शियम, इट गेव 3.5 ग्राम ऑफ कैल्शियम ऑक्साइड, राइट। कितना ऑक्सीजन लिया 1 ग्राम। दोनों ही केस में हमें कैल्शियम ऑक्साइड मिल रहा है, लेकिन उनके जो सोर्सेज हैं वो अलग हैं। अब हमें लॉ ऑफ डेफिनेट प्रोपोर्शन के लिए इनका रेशियो निकालना होगा। सो वी विल कैलकुलेट द रेशियो ऑफ कैल्शियम ऑक्साइड ओवर ऑक्सीजन। सो यहाँ पे क्या हो जाएगा 2.8 अपॉन 0.8, इट गिव्स मी 3.5. Similarly, in the second case, it also gives me 3.5. Since the ratio is coming out to be same, that means the law of definite proportion is verified. The next law talks about law of multiple proportions. So it was put forth by Dalton in 1803. He stated that if two elements can combine to form more than one compound, then the masses of one element that combined with a fixed mass of other element are in the ratio of small whole numbers. Let me explain this with an example. Let's say hydrogen combines with oxygen to form two compounds, namely water represented by H2O and hydrogen peroxide represented by H2O2. ठीक है, तो यहाँ पे देखो हाइड्रोजन प्लस ऑक्सीजन गिव्स वाटर एंड इन द अदर रिएक्शन इट गिव्स हाइड्रोजन पेरोक्साइड. So here you can see that hydrogen and oxygen have formed two types of compound. One is water and one is hydrogen peroxide, right? Now as per the law, it says if one element that combined with fixed mass of other element. So fixed mass of other element here it refers to mass of hydrogen, right? तो जो दूसरा element होगा उसके masses का जो ratio होगा that will be a small whole number ratio. So if I take the ratio of masses of oxygen, that comes out to be 16:32, and the simplest ratio will be 1:2, right? So this was stated by Dalton. See this question, it says verify the law of multiple proportion in the following, and this data is given to you. So as you can see here, we have two elements which is carbon and oxygen, right? Here 1 gram of carbon is combining with 1.33 gram of oxygen to form carbon monoxide, and here it is combining with 2.66 gram of oxygen to form carbon dioxide. So law of multiple proportion क्या कहता था, दो elements होने चाहिए, तो हमारे पास दो हैं कार्बन और ऑक्सीजन, और ये दो compounds form कर रहे हैं which is carbon monoxide और carbon dioxide, ठीक है। तो एक element का mass fixed होना चाहिए which is fixed here 1 gram. So mass of carbon is fixed. So as per this law, if the ratio of masses of other element comes out to be simple whole number, then this law is verified. So let us find out the ratio of masses of oxygen. So it comes out to be 1.33 is to 2.66. If I see the simple ratio, then it comes out to be 1:2. Since it is a whole number, therefore this law is verified. Next law is Gay-Lussac laws of gaseous volumes. So he was a scientist and he gave this law. What he stated is that when gases are combined or produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. So what conditions he took was same temperature और pressure होना चाहिए सारी gases का during a chemical reaction, ठीक है। I can explain you with an example wherein 100 ml of hydrogen combined with 50 ml of oxygen to yield 100 ml of water vapor. So as per this law, it means that जो भी gases combine करी, here hydrogen and oxygen has combined, तो उनका अगर हम ratio निकाले, which comes out to be 2:1, so this ratio is also a simple ratio by volume. क्योंकि हमने volume का ratio निकाला है, इसलिए हमने इसको by volume बोला. So this law is also referred as law of definite proportions by volume. Let's see this question. It says 2.5 ml of gaseous hydrocarbon exactly requires 12.5 ml of oxygen for complete combustion and produces 7.5 ml of carbon dioxide and 10 ml of water vapor. All the volumes are measured at same temperature and pressure. Show that the data illustrates Gay-Lussac's law of volume combination. So इसमें as you can see that सेम टेम्परेचर और प्रेशर हमें दिया हुआ है, दिस इज सेम फॉर ऑल गैसेस, राइट. और जो हमारा रिएक्शन है उसमें भी हमारे रिएक्टेंट का प्रोडक्ट सारे ही गैसियस स्टेट में प्रेजेंट है. सो वी कैन अप्लाई दिस लॉ. सो एज पर दिस लॉ व्हाट वी हैव टू डू इज दैट जो भी वॉल्यूम ऑफ हाइड्रोकार्बन है उसका रेशियो देखेंगे विद ऑक्सीजन. सो वो क्या हो जाएगा, 2.5 ml is to 12.5 ml and it is coming out to be 1:5, right? So this is a simple whole number ratio. Therefore, this law is verified. The last law is Avagadro Law. Avagadro was a scientist who gave this law in 1811. He proposed that equal volume of gases at same temperature and pressure must contain equal number of molecules. ठीक है, so what condition he gave was same temperature and pressure. तो उसमें क्या बोला, जिनकी इक्वल वॉल्यूम होगी गैसेस की उनके इक्वल नंबर ऑफ मॉलिक्यूल्स भी होंगे. जैसे ये एग्जांपल लेते हैं, यहाँ पे क्या है, टोटल ओवरऑल 2 वॉल्यूम ऑफ हाइड्रोजन रिएक्ट विद 1 वॉल्यूम ऑफ ऑक्सीजन टू गिव 2 वॉल्यूम ऑफ वाटर वेपर. ठीक है, अगर मैं वॉल्यूम्स की टर्म में देखूँ तो देखो यहाँ 1 वॉल्यूम ऑफ हाइड्रोजन और 1 वॉल्यूम ऑफ ऑक्सीजन को कंपेयर करते हैं. इसके नंबर ऑफ मॉलिक्यूल्स कितने हैं, 1 2 3 4 एंड 5. सिमिलरली 1 वॉल्यूम ऑफ ऑक्सीजन में भी कितने मॉलिक्यूल्स हैं, 2 3 4 5. सिमिलरली अगर हम 2 वॉल्यूम्स ऑफ हाइड्रोजन और 2 वॉल्यूम्स ऑफ वाटर वेपर देखें तो 2 वॉल्यूम्स में कितने हो जाएंगे, 10 मॉलिक्यूल्स, और वाटर वेपर के ओवरऑल कितने मॉलिक्यूल्स हो जाएंगे, इफ यू काउंट दिस कम्स आल्सो आउट टू बी 10, राइट. So this law is verified. So you have understood the laws of chemical combination. Let us now understand Dalton's atomic theory. So this theory could explain the laws of chemical combination. Some of the key postulates of this theory is, number 1, matter consists of indivisible atoms. So atoms cannot be divided further. However, this theory was later proved to be wrong as we go on and study in the chapter called as structure of atom. But till now, you should understand this, that as per this theory, matter consists of indivisible atoms. Second point says all the atoms of a given element has identical properties, including identical mass. Atoms of different elements differ in mass. So suppose I have an element hydrogen. It is made up of hydrogen atoms and all the atoms have same mass, which is mH, let's say. And I have another element, oxygen. It is made up of oxygen atoms and all the atoms of oxygen will have mass as MO. So mass of hydrogen would not be equal to mass of oxygen atoms, right? Third point says compounds are formed when atoms of different elements combine in a fixed ratio. We have already studied this in our lecture 1, that how compounds are formed. Fourth point is chemical reaction involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Since you have got a decent knowledge about what atoms, molecules, elements, compounds are, what are the laws, now let us try to understand the terms such as atomic mass and molecular mass. First, we will discuss about atomic mass. As the name suggests, it represents mass of one atom. तो earlier 19th century में scientists mass कैसे निकालते थे एक atom का? They used to determine the mass with respect to another. सो उसके लिए हाइड्रोजन का मास असाइन किया इन्होंने 1 विदाउट एनी यूनिट और कॉरेस्पॉन्डिंगली दूसरे एलिमेंट्स का मास निकाला. कैसे कैलकुलेट करा? सपोज एटॉमिक मास ऑफ एन एलिमेंट वाज इक्वल टू वेट ऑफ वन एटम ऑफ एलिमेंट डिवाइडेड बाय वेट ऑफ वन एटम ऑफ हाइड्रोजन. सो प्रेजेंटली क्या होता है? अ सिस्टम ऑफ एटॉमिक मास इज बेस्ड ऑन कार्बन 12 एज द स्टैंडर्ड. तो हुआ क्या कि कार्बन 12 आइसोटोप को असाइन किया मास ऑफ एग्जैक्टली 12 एटॉमिक यूनिट, AMU से रिप्रेजेंट करते हैं, और masses of other elements were determined relative to it. So one atomic mass unit को हम कैसे define कर सकते हैं? As the mass exactly equal to 1/12 the mass of carbon 12 atom, right? So relation between 1 AMU and gram was found to be this. 1 AMU equals to 1.66 into 10⁻⁻24 gram. So अगर मुझे कोई एटॉमिक मास ऑफ एलिमेंट को डिटरमिन करना है, so what I will do is I will equate it with weight of one atom of element divided by 1/12 into weight of one atom of carbon 12. So nowadays AMU is replaced by U and it is also known as unified mass. When we use atomic mass of elements in calculations, we consider the average atomic mass of it. So many natural occurring elements also exist as isotopes. Isotopes are the ones having same atomic number but different mass. Example, hydrogen has 3 isotopes as hydrogen 1, hydrogen 2 is deuterium and hydrogen 3 is tritium, right? अब isotopes exist कर रहे तो हम क्या लेते हैं? इनका average atomic mass calculate करते हैं. How we will compute it? As we take the sum of exact weight of isotope into percentage abundance of isotope divided by 100. Let me explain this with a calculation of carbon isotope example. So in this table you are given the carbon 12, 13 and 14 isotope and the corresponding relative abundance, and the atomic mass is given for each isotope. Now, if you have to calculate the average atomic mass of carbon, it will be equal to percentage relative abundance, which is 98.892 into 12, since we are calculating for carbon 12, and similarly for carbon 13 and carbon 14. So, unit will be unified mass, right? So, the net result comes out to be 12.011 unified mass. तो जैसे एटम का मास एटॉमिक मास कहलाता है, वैसे ही मॉलिक्यूल का मास मॉलिक्यूलर मास कहलाता है. तो मॉलिक्यूलर मास इज द सम ऑफ एटॉमिक मासेस ऑफ एलिमेंट्स प्रेजेंट इन अ मॉलिक्यूल. अगर हमें कैलकुलेट करना हो तो इट इज गिवन बाय समेशन ऑफ एटॉमिक मास ऑफ एलिमेंट इनटू नंबर ऑफ इट्स एटम. लेट मी एक्सप्लेन दिस विद एन एग्जांपल. जैसे CH4 ले लिया. अब CH4 के अंदर एक कार्बन एटम है और 4 हाइड्रोजन एटम है. तो इसका मॉलिक्यूलर मास अगर निकालना है तो क्या हो जाएगा? समेशन ऑफ एटॉमिक मास ऑफ कार्बन इनटू 1, बिकॉज एक एटम है कार्बन का, प्लस एटॉमिक मास ऑफ हाइड्रोजन इनटू 4, बिकॉज 4 हाइड्रोजन एटम्स आर प्रेजेंट. So if we put the atomic mass values, then we get the final molecular mass of methane as 16.043 units. Let us discuss about formula mass. So there are some substances, mainly ionic compounds, which do not exist as discrete molecules, like NaCl. You can see it in this picture as well. So this picture is of NaCl packing. So as you can see, there are a lot of molecules that join together to form a 3D structure. In such cases, the formula such as NaCl is used to calculate the formula mass instead of molecular mass. As you know that a molecular mass is for one molecule only. So ऐसे compounds का हम formula mass calculate करते हैं. कैसे calculate करेंगे? It is shown by an example. Suppose formula mass of NaCl निकालना है, तो simply atomic mass of sodium और atomic mass of chlorine को add कर देंगे. 23 is the atomic mass of sodium and 35.5 is the atomic mass of chlorine. So the net result is 58.5, which gives me the formula mass for NaCl. So I hope आपको आज के सारे concepts समझ आ गए होंगे. I will continue this chapter in my next lecture video. I strongly recommend you all to get yourself enrolled to EduRev Infinity program, as you can try the mock test after watching each video. You can even get access to all the subjects in just one subscription, and you can access lot of questions, even more than 10,000 questions for practice. And this content is verified by highly qualified teachers. So do try this and do enroll yourself to this program. Thank you.